This video is for class 9 physics, and in this video we are solving the numerical problems from exercise 3C, that is from Newton's second law of motion. Before going to the question, let us write some formulas which is required and which we learned from this section. So first one was number one was momentum, that is linear momentum equals to mass multiplied by velocity, and the second one is force equals to mass into acceleration. There were few more like rate of change of momentum was also equal to mass into acceleration, and there was last one which was rate of change of momentum equals to force into change in time, small time, del t, or simply you can write just t. So these were the few formulas which we learned. So if required, then we'll use them all. If not, then we can use the first one and two. A part of these formulas, I think we need to use equations of motions also. So therefore, please be familiar with those formulas also. Now we can go to the question. Okay, please refer your book for the question if it is not visible on the screen. The first question reads as: a body of mass 5 kg, so mass is given to us, is moving with the velocity of 2 meter per second. So velocity is given, so mass is given and velocity is given. Calculate its linear momentum. I think this is a straightforward question. So let us solve. Okay, coming to its solution. Given mass is 5 kilograms, velocity is 2 meter per second, and momentum is question mark. Here, using the formula for momentum, that is linear momentum, P equals to m into v, and then replacing the values of m, which is 5 kilograms, and velocity, which is 2 meter per second, I am multiplying it and I am getting as 10 kilogram meter per second. I think this was quite simple, and you can do by yourself also. So let us go to the next question. Question number 2 reads as: the linear momentum of a ball of mass 50 gram. So momentum given to us is the mass given to us is 50 gram, is 0.5 kilogram meter per second. You can see the difference in the unit here. Mass is expressed in CGS, whereas momentum is expressed in SI unit. So you are supposed to find its velocity. So let us go to its solution. So coming back to its solution, given mass is 50 gram and I have converted it into kilogram by dividing it by 1000, right? Next we have momentum equals to 0.5 kilogram meter per second. So using the formula for momentum, which is P equals to m into v, and then cross multiplying it, I am getting v equals to p by m, linear momentum by mass. Again, then replacing the values, that is 0.5 upon 50 upon 1000. Here you can see kilogram and kilogram gets cancelled. So I hope you know this solution here. This, I think you are mature enough to do this kind of cancellation, right? So after cancellation, I am getting v equals to 10 meter per second. So this is my answer. If you don't know how to cancel it, please practice cancellation, right? So then we can go to the next question, which is question number 3. Question number 3 reads as: a force of 15 Newton acts on a body of mass 2 kg. A force of 15 Newton acts on a body of mass 2 kg. Calculate the acceleration produced. So here I think we have to use the second formula, right? Let us go to the, so given force is 15 Newton, mass is 2 kilogram, using the formula for force, which is force equals to mass into acceleration, and then again cross multiplying it, I shall get the formula for acceleration, which is acceleration equals to force by mass. Then replacing the value of force and mass, here I have forgotten to write kg, so 15 Newton upon 2 kilogram here. So I shall get 7.5 Newton per kilogram, which is meter per second square. So again then you might ask, how is Newton per kg this here is equal to meter per second square? So as you all know, if you have watched previous videos about the units of force, then Newton was equal to kilogram meter per second square. So Newton per kg will be kilogram meter per second square divided by kilogram. So you can see kilogram and kilogram is getting cancelled. So hence we are getting meter per second square. This is how it is done. Okay, then we can go to the next question, which is question number 4. Okay, coming to the question number 4, a force of 10 Newton acts on a body of mass 5 kg. Find the acceleration produced. That means it is same as number 3. So if you think you can do it, so please do it by yourself. Pause the video and try to do it by yourself. It is very simple. It is same as number 3, but if you are finding any difficulty, again I have solved it for you, right? Let us go to the solution then. Let us try to solve number 4. Number 4, right? Things given to us: force equals to 10 Newton and mass is equal to 5 kilogram. So using the formula F equals to m multiplied by a, I think you can solve this further. Okay, I think you can solve this further. So please try to solve this. This is quite easy, right? So you can go to the next question, which is question number 5. If you read the question number 5, calculate the magnitude of force which, when applied on a body of mass 5 kg, produces an acceleration of 5 meter per second square. So I think this is very simple, right? We just have to use the formula F equals to m into a, that is F equals to m multiplied by a. M is given, acceleration is also given. So please try number 5 by yourself, right? I think you can do number 5. Let us go to the next question, which is question number 6. A force of 10 Newton acts on a body of mass 2 kg. A force of 10 Newton acts on a body of mass 2 kg. So things given to us: force and mass for 3 seconds. A new thing is given to us here. For how many seconds? 3 seconds. Initially at rest. Again u equals to 0. Calculate the velocity acquired by the body and the change in momentum of the body. So two things are given. I don't think so it's as simple as number 5 and 4. So I have done the solution for you all. So let's see, go to the solution. Okay, we have come to the solution. Given force is 10 Newton, mass is 2 kg, time is 3 seconds, and initially it was at rest. So therefore initial velocity here, initial velocity is 0. Initial velocity is 0 here. Initial velocity is 0. So using the formula F equals to m into a, I can find the acceleration, right, which is 5 meter per second square. So why do I need to find the acceleration? Because we are supposed to find the velocity, right? And to use the equation of motion, I need acceleration. I hope you understood till here, right? Then we can go to the next line of the solution. V equals to u plus at. This is number 1. Okay, V equals to u plus at. So V equals to u plus at. Using this formula, u is 0, a is 5 meter per second square. Just now we calculated here, and time given to us was 3 seconds. So I have written 3 seconds. This second and this second gets cancelled, and hence I am getting V equals to 0 plus 15. That 5 into 3 is 15, and I am getting V as 15 meter per second. So then this is the first part. Then we can go to the second part, which is change in momentum. That is final momentum, that is final momentum minus final momentum minus initial momentum, final momentum minus initial momentum. Since u was 0, initial momentum was initial velocity was 0, therefore my momentum will also be 0, right? Now continuation part here. Now I am supposed to find the final momentum. Final momentum P2 equals to m into v, right? Mass given to us is 2 kilogram. Velocity just now we calculated as 15 meter per second. Therefore P2 is equal to 2 into 15 gives me 30 kilogram meter per second. So what will be the change in momentum then? The change in momentum will be P2 minus P1. The change in momentum will be P2 minus P1, right? P2 minus P1, which is 30 minus 0, hence my final answer will come 30 kilogram meter per second. So this is how we have done